Okay, hi everyone. So welcome back. So now you're going to move to example B. Okay. So again, there are two domains you have to consider. Why? Because you see, there's a unique piece of a function for all the x value less than positive one, and you have a function, unique piece of a function where the x value are greater than one. Okay, so there are two domain restrictions. Okay, so let's continue. So I want to find out the domain restriction first. Okay, on the left one. Okay, on the left side for all the x value less than one. Okay, so if you know, remember all the number on the left side of one are going to be less than. Okay, so to write this as an inequality, you're going to start with x. Okay, less than, and it's going to be 1. Now at 1, I need to find out if we have a full dot or open dot. So I see here you have an open dot, okay? Because it's open, okay, there's no line under the inequality. Why? So if we're saying that when x is equal to positive 1, okay, the x value cannot, so the x value cannot be 1. Okay, you have to be less than 1. The same, if I look on the area, the region of the number on the right side of 1, okay, you can see that at 1 there is an empty dot, okay, on the line of the function, which means that for the inequality there's no line under the inequality. So I'm going to write here x, the number on the right side of 1 are greater than 1, as we can tell. So 10 is greater than 1, right? So I have to the greater than symbol, the arrow pointing to the right for greater than. Okay, no line under the inequality. Why? Because on the x equal 1, the line we have empty dots there. Okay, so you have to write the functions. Like before, you need to find what is m. Okay, what is b. Okay, on the left side. So let's do this. So to find what is m, I need to pick two exact. I need to choose exact point. Identify the exact point. There's one here, one over here. Okay, there's one over here. So basically, there are points that are on the line and that are also on the corner of the unit square. Okay, so now I have to find the slope. I told you before, you want to go up one. Sorry, you want to go from left to right. Okay, so let's find the slope. Let me use my pencil. You're going up how many times? 1, 2, 3. So you're going up 3 times. So positive 3. What is the run? So you're moving to the right how many times? 1 times. So you're moving to the right 1. So the run is positive 1. And 1 goes into 3 times. So now let's do that. So we start here. So you go up. So how many times? Let's check our slope again. So how many times are you going up? 3 times. 1, 2, 3, and you move to the right 1. You're going up to 3 times and to the right 1. 3 up 3 into the right 1. So the slope is correct. So I know that m is positive 3. So now what is the y-intercept? The y-intercept is the point of intersection between the y-axis and the y-axis and the line. And the point of intersection is positive 1. So the equation of a line is going to be y equal 3x plus 1. Okay, so now to graph the function, to write the function in the piecewise format, I'm only going to use this, the expression 3x plus 1. I'm going to drop the y and equal sign right here. So 3x plus 1. So now on the left side, okay, how do we do that? So identify the exact point. I have one here, one over here, one. So I have a couple of them. So let's find the slope. What is m equal to and what is b? So again, the slope here is what? So again, I move from my left to my right. Why? Because usually write from left to right. So if I start from here, what is going to be the rise? We are going down 1 unit. Okay, so the rise is going to be -1 because you're going down 1, and then you're moving to the right 1. So it's -1 over 1 and -1 over 1. So 1 goes into 1 once, and negative divided by positive is a negative. Okay, so M is -1. And what is B, the y-intercept? So, okay, if you don't believe me, so you can try for the slope, do back a couple times. You're going down 1 and to the right 1, down 1 and to the right 1, down 1 and to the right 1. Okay, so you're going down 1. Because you're going down 1 is negative. And because you're going to the right is +1. Okay, so I am correct. So now the y-intercept, again, we want to continue the pattern of a line until it crosses the y-axis to identify the y-intercept. Okay, so instead of going down 1, I'm going to go backward. Okay, I'm going to go up 1. Okay, and I'm going to move to the left. So I'm going to go up 1 and move to the left 1. Then I'm able to see that the y-intercept is +2. So the y-intercept is right here. It's +2. Why? I did the opposite of the direction of the slope from this point here to continue the line. So instead of going down, I'm going up 1, and instead of going to the right, I'm going to the left. Okay, so B is +2. So the equation of a line is y equal -x, -1x, okay, -1x plus what? +2. So now, as mathematician, we don't write the 1, you drop it. So I'm going to write -x plus 2. So that's the expression I'm going to use in the piecewise, as a piecewise defined function, the second one. So I'm going to write -x, okay, plus 2. Okay, so we are done with the example B. Okay, so I'm going now to move example C for checking for understanding. Okay, bye. See you into the next video for example C.